You remember it, right? That shiny, spinning disc. The one that held your favorite album, or that blockbuster movie, or maybe that one video game you poured an entire summer into. Well, today, we're telling its story. We're going to dive into the biography of the optical disc, from its absolutely revolutionary rise to its, well, surprisingly important role in our world today.
All right, so let's pop the hood and see what we're working with. Here's our roadmap for this journey. We're going to start with the magic of how they even work, trace the family tree from the classic CD all the way to Blu-ray, and then we'll uncover the secrets of how a laser actually reads the data. After that, we'll weigh the pros and cons, and finally, we'll explore its lasting legacy.
So first things first, what was the big idea here? I mean, how did we manage to pack so much information onto what's basically a simple piece of plastic? It really all comes down to the magic of light.
Of course you do. That sound, that feeling. For so many of us, that was the soundtrack to our digital lives for decades. This piece of tech was absolutely everywhere. And believe me, it was for a very, very good reason.
You know, at its heart, the whole concept is just incredibly elegant. It's all about using a laser, a super focused beam of light, to first imprint and then interpret digital data on a disc. Just think of it like a physical library where the librarian is a tiny laser beam. And you can't overstate the impact. It was massive. Before streaming, before flash drives, this was it. This was the whole game. If you wanted to buy music, if you wanted to install software on your computer, or watch a high-quality movie at home, you were buying an optical disc. They were truly the main vehicle for distributing digital content to the world. But you know, that original disc didn't stay the same for long. Not at all. The technology evolved, and it evolved fast. Each new generation brought this huge, incredible leap in what was possible. And this timeline just shows that progression perfectly. It all kicked off in the early 80s with the compact disc, the CD, which completely revolutionized the music industry. Then, bam, in the mid-90s, the DVD comes along and changes home video forever. And finally, in the mid-2000s, Blu-ray shows up, kicking off the whole age of high-definition media.
Now this is what's really wild, the sheer scale of the jump in storage. A CD could hold about 700 megabytes. Okay, cool. But a standard DVD, 4.7 gigabytes. That's almost 7 times more. But then Blu-ray comes along with 25 gigabytes on just a single layer disc. That's a 35-fold increase from where we started with the CD. Just incredible.
Okay, so we know they hold a ton of data, but how does it actually work? How in the world does a laser pull your favorite song or an entire movie from a flat, spinning piece of plastic? Let's get into the secret life of the disc.
So first we gotta understand the anatomy of a disc, because it's not just one piece of plastic. It's more like a sandwich of 4 key layers. You've got the label on top with the artwork, then a clear protective layer, then a super thin reflective layer, and finally that transparent polycarbonate base that holds the data. Now that third layer, the reflective one, that is where all the real action happens.
And here it is, the core concept. All your data, every 1 and 0, it's not just some abstract thing. It is physically imprinted onto that reflective layer as billions of microscopic bumps. The little indentations are called pits, and the flat areas in between are called lands.
So here's the crucial part, how these pits get made and how they get read. To write data, a really high-powered laser actually burns these tiny little pits into the reflective layer. But to read it all back, a much weaker, low-powered laser is used. It just scans the surface, it doesn't change a single thing.
So when that low-power laser hits a flat land, the light reflects back nice and bright. But when it hits a pit, the light scatters and reflects back dimly. The disk drive sensor sees this changing pattern of bright and dim, and translates that pattern back into the 1s and 0s of your digital file. It's that simple, and honestly, that brilliant. So now we know how it works. But what was this technology actually like to live with? Well, like any great character, the optical disc had its heroic strengths and its fatal flaws. Yeah, this slide lays it out perfectly. On the plus side, they were tough. They had a really long lifespan, they held a ton of data for the time, and they were resistant to stuff like humidity. But on the downside, and we all remember this, the weight, they could be so slow to access data. They were famously vulnerable to scratches. And who hasn't dealt with the format wars? You know, Blu-ray versus HD DVD? That stuff created major compatibility headaches. But let's talk about one of its hidden superpowers, error correction. See, the designers knew these discs would get dusty and scratched up. So they built in these incredibly sophisticated systems that could mathematically figure out and reconstruct missing data on the fly.
That is the reason a slightly scuffed CD could often play through without a single skip. It was genius.
Okay, so where does that leave our hero today? In a world of instant downloads and cloud streaming, has the optical disc just become a relic? Well, not quite. Its story has a pretty fascinating final chapter.
I mean, let's be real. For everyday use, the disk has been pretty much replaced. USB drives are way more portable, external hard drives offer way more space, and the cloud, well, the cloud offers convenience you just can't beat. The disk definitely lost the battle for our daily data needs.
But here's the twist. The optical disc has found a new and actually vital role. Just like this quote says, it turns out it's the ideal format for archiving, for long-term, super secure data storage. And why is that? Well, because its data is physically etched into the disk itself. It's not a magnetic charge that can fade over time or get wiped by accident. This makes it incredibly stable over decades. So when you need to be absolutely positively sure that your data will be readable in 50 years, you don't put it on a hard drive, you burn it to an archival-grade optical disc.
Which kind of leaves us with a final thought, doesn't it? In our world, data feels so intangible, so temporary. It's just a file we can delete with a single click. But the humble optical disc is a powerful reminder of the security you get with a physical record. It really makes you wonder, maybe the safest way to preserve our history isn't just in the cloud, but etched permanently onto a simple piece of plastic.